Hello everyone, this video will demonstrate SpecChecker-ISA, a data sharing analyzer for interrupt-driven embedded software. Interrupt-driven programs are widely used in safety-critical areas, including aerospace, automotive electronics, medical equipment, and so on. Interrupts introduce fine-grained concurrency into software, making them prone to concurrency bugs, for example, data races and atomicity violations, which often come from the complex interactions among tasks and interrupts on shared data. Therefore, data sharing analysis is crucial to reasoning about the concurrency behavior of interrupt-driven programs, from program comprehension and code inspection to bug detection and verification. There are some tools related to the data sharing analysis, TSA, and SpecChecker. However, they cannot reason about the numerical value of pointer variable and array index, which limits their ability to acquire comprehensive and accurate results of data sharing analysis. We propose SpecChecker-ISA to provide sound and precise data sharing analysis for interrupt-driven embedded software, and supports various data sharing forms and granularity, for example, global variables, pointer aliasing, array elements, struct/union fields, and I/O address pointers. And SpecChecker-ISA can aid embedded software testers during manual code inspection for concurrency bugs. Researchers and developers can also use it as a solid front-end of concurrency bug detection tools for interrupt-driven embedded software. Our tool takes the source code and task/interrupt configuration as input, then uses pointer analysis and abstract interpretation-based value analysis to infer the base and offset for each access, respectively. Finally, it identifies all potential shared data accesses between tasks/interrupts using the meet operation of the numerical abstract domain. This video shows how to obtain our tool, and it also shows how you can apply the tool to an example with shared data. This is the official website for the project that contains the executables of the tool and detailed instructions on its usage. I'm just following the instructions given on this website so that you will know where to look on this website to get access to objects as quickly as possible. I'll be using a Windows machine for this purpose. The first step is to make sure that you have the appropriate tools installed on your computer. You need Python 2.7 or higher, and you can install it by this link. Then you will need to clone the repository on your local machine. For that, you can use the following command. Provided that you have Git installed on your system, you will be able to download the project without any problem. Now, the tool is ready to use. I'm using the example that is shipped with this repository. This includes two kinds of files that can be used as input, test.bc or test.c. If you use the BC file as input to the tool, you must have Clang on your machine. The installation link is given on our website, or use the executable we provide in the bin folder. Then I will use Clang to compile the source file to the BC file. This is done by simply using the following command. After it is done, you will get the corresponding BC file. Before running the analysis tool, let's analyze this case, which involves 8 accesses to shared data. The main program and interrupt call I/O outset and I/O out CLR, respectively. In I/O outset, the variable is read from the address, and the result of calculating the variable VAL is written to the address. Next, assign the global variable GV to the first and second elements of the array upload data. In I/O out CLR, the variable is read from the address, and the result of calculating the variable VAL is written to the address. Next, assign the second element of the array upload data to the global variable GV via the alias. In this case, access to shared data includes access to I/O data via address pointers dereference, access to array elements, and access to global variables. Then I will use SpecChecker-ISA to analyze the BC file. This is done by simply using the following command. I'm copying and pasting the command for invoking objects. These command line parameters include the analyzed file, task entry and corresponding priority, interrupt entry and corresponding priority, and output folder. For demonstration, I created a new folder demo. Let's see what the output is after the run is over. This directory contains 2 files, result.csv and result.json. Let's take a look at the output of the tool through the CSV file. This file for each shared access includes detailed information, including the base, offset and size of the shared data, access mode, the name of the task/interrupt where the access occurs, the source file path, and the code location, line and column. Taking the shared data upload_load, 1, as an example, we use base, offset, and size to indicate that the shared data is the second element of upload_load. The read access comes from the entry of interrupt service routine named ISR, the function name is IOOutCLR, and the write access comes from the function IOOutSet of the main task, and their source code information. Thanks for watching.